Let's talk about this vector lab. Now, before I really get into it, I just want to say, if you haven't watched them already, there are 2 videos in the homework, vector components and trig relationships and adding and subtracting vectors. And I definitely recommend watching those in addition to this one. I think all of them will help cover all the material with regards to vectors that you need. But this video is going to focus specifically just on this lab. So it'll talk about things that are already in those other 2 videos. So what you've got here are a whole bunch of vectors, but of course the information's incomplete. We've got, say here, the components, but you don't have the magnitude and the direction. Or you've got the magnitude and the direction, but you don't have the components. Or you've got the direction and only one of the components, and you've got to get the rest. Or even down here, which is a really interesting case. This is where you have one of the components and the magnitude, but you don't have anything else. And we'll talk about that one because that one's not as straightforward, not as obvious as these others. So the first thing I recommend doing here with all of these is drawing your vector. So for example, if I'm drawing my first vector, so set 1a for me, I've got a negative x component and a negative y component. So that puts my vector here, oops, down in the 3rd quadrant. And I think it's very useful to draw this to, if only for the visual, so you can see it, see which way it's pointing. Now, once I've done that, I already know my components. If I want to get the angle, remember that theta equals the arctangent. Now theta, I've been saying that theta is the angle relative to the horizontal. So this is theta right here. So it's the arctangent of the y component over the x component. We're taking the absolute value. So we're going to get a positive angle. Now in the lab, however, the angle that you need to give is counterclockwise from the positive x-axis. So it's, oops, let me undo that. So it's all this way. That's the angle that you need to get. It's counterclockwise from the positive x-axis. So hopefully you can see that we're starting here 0, that's 90 degrees. Now we've gone 180, so we got to go 180, and we're going to have to add that extra. So this is a big reason why it helps to draw the vectors, so you can see how to get this angle that you're asked for. Now you might get, sometimes you might, for whatever reason, have or get the angle relative to the vertical. And that is calculated doing, instead of y over x, it's x over y. And in that case, if I knew this angle, I'd be going 90, 180, 270, and then I'd have to go back. I'd have to subtract away this angle. So that's how that works. Now I did one from set 1 where we have the components. Let's take a look at one of these others. Let's take a look at, how about this one here? So for me it's 2b, set 2b, and I'm told that the angle is 339 degrees. Okay, so if I'm drawing this one, so this particular one, that was 339 degrees, so I've got to go 0, 90, 180, 270, so 339 is going to put it somewhere over here. I'm just kind of guesstimating what it is. So that's 339 degrees all the way around. So that's going from here all the way around to there. All of that is my 339 degrees. Now I know all the way around is a circle, all the way around to make a circle is 360 degrees. So that must mean then that this angle here is 21 degrees. So now I know the angle relative to the horizontal. And of course I could quickly get the angle to the vertical if I wanted to. That's going to be 90 minus 21. And so that would just be 69 degrees. But again, it really helps to draw these vectors. so you can see what's going on. Now, negative a, because I know that's another issue that people have been getting hung up on, trying to figure out negative a. Remember that negative a is just anti-parallel to a. That is, they're 180 degrees apart. So if going back to my first vector, if that's pointing this way, well, then negative a has got to be pointing the exact opposite direction. So this is negative a, and that's a. They're anti-parallel. They're pointing exact opposite directions. This angle here, I already said is theta. Well, if they're truly anti-parallel, guess what then? This angle over here, this angle of the horizontal, still theta. They're anti-parallel. They're 180 degrees apart. And that's really all there is to it. I can draw any other vector I want. I'll go ahead and draw the other one that I did. There you go. So I know they're all called A, but just to call it something different so we don't get confused, this would be negative B, and this would be B, way down here. So that's how you're figuring out negative A. Now, how do you get all these other things? I went over how to get the angle. What about getting the magnitude, or what about getting the individual components? Let me just remind you, of course, of the Pythagorean theorem. That's obviously very useful here. Additionally, let me remind you of the formulas for the x and y component. So it's plus or minus, if I want the x component, it's plus or minus a cosine of theta, where theta is the angle to the horizontal. Or I could do plus or minus a times the sine of phi, so that's the angle relative to the vertical. So I could choose to do that. If I'm doing the y component, same thing. This is plus or minus a. This is the sine of theta, so sine of the angle relative to the horizontal. Or if I'm using the angle relative to the vertical, then it's the cosine. So notice with these formulas here that I have, so for example, this one here, if I know the magnitude and the angle, then obviously I can get the x component. Or if I know the x component and the angle, then I can figure out the magnitude. If I know two of the three unknowns, I can get the other one, whether I'm talking about these ones here or these ones here. The last thing that I wanted to go over were sets 5 and 6. I already mentioned these are kind of an interesting case. They're different than the others, and that has to do with the Pythagorean theorem. So you can see for sets 5 and 6, you're only told one of the components and you're told the magnitude. So if we come down to the Pythagorean theorem, and let me just kind of do this on a fresh page. So if I were to solve, I'm going to solve for the y component. So that's going to be ay squared equals a squared minus ax squared. And so you take the square roots, but remember the square root is a multi-valued function. So it's plus or minus the square root there. So you have to choose the plus or minus. And let me add, it's the same thing actually here. You have to choose whether these are plus or minus. That's based on where your vector is, what quadrant it's in. If you don't already know the x component, you have to draw it ahead of time so you know what component, whether the components are positive or negative. But going back to here, we were only told the magnitude and, in this case, say the x component. So I don't know if y is positive or negative. So let's look at my case. So for set 5, I had a positive x component. Okay, so if I draw that, let me draw that real quick. I have a positive x component. So a positive x component means that it could be pointing this way with a positive y component, or if the y component's negative, then it's pointing down this way, where my drawing isn't perfect, but regardless of whether the y component is positive or negative, it's going to have the same angle relative to the horizontal. Now you can see these two vectors are pointing in different directions. And so that's why, if we come back up to here, that's why it says, okay, what's the angle for A if you had a positive y component? What if you had a negative y component? What's the angle going to be? So in my case, if for the positive y component, I would just find this angle theta using the arctangent, and then that would be my answer. But for the negative, okay, it's negative. How am I going to get that? Well, a couple ways, but I've got to, you could bear in mind that it's 270 degrees to here, or the fact that it's 360 all the way around, and then use theta to, in both cases to figure out the rest, because you're trying to go all the way around. So if I go to 360, then obviously I've got to come back to theta, because I've got to subtract that. If I only go to 270, then I have to add whatever this angle is, whatever that is, and of course, in terms of labeling it, that's phi. Okay. Now, the other thing, though, is we also need the angle of negative a for when it's a positive y component for a and when it's a negative component for a. So in that case, we've got, just to draw these out, we've got two options. This is one of them. It's roughly correct. Or it could be down here. That one is. There we go. So if my vector had a positive y component, then this is the negative of the vector. If my vector had a negative y component, then this is the negative of a. Yeah. So it helps to draw the vectors out. Use a standard Cartesian coordinate system, you draw your axes, then you draw your vector. Which quadrant is it in? You draw it. Or in this case, I drew the two possibilities. And then I use that to inform my thinking, to inform my analysis, to help me figure out what the angles are and whether my components are going to be positive or negative, if I don't already know. So this is really how I think you should be approaching these problems in the lab, especially if you are struggling a little, you don't immediately see what to do. This is a good approach. Draw it, work it out. Again, the formulas that you need, it's just the Pythagorean theorem. You need the Pythagorean theorem, and you need these arctangent ones and these relationships for the components. That's what you need. Draw the vectors, use these, and that's all you need to go through and find all these answers. Hope this helps.